Okay, everybody. So these are going to be solving for unknown angles, but we're going to use angles in a triangle and stuff. So this first one, it's back to our transversals. So let's look at this. So we're going to find the measure of angle x in the figure to the right. Explain your calculations. So it gives us the hint of drawing an auxiliary line, but honestly, whenever we see something that's not a transversal, that has this little break right here. So if this line had continued all the way like this, we would have been good to just use our parallel lines, use our transversals, but we can't do that. So we're going to make a little line that we're going to say is parallel to this, and once we've defined it as parallel, we can put it anywhere we really want. So as long as we know for a fact that it is parallel to these two lines, then we can do this. So this is going to allow us to use our typical transversal tricks. One thing that you're going to get used to is math is all about reducing things to something we know how to do. And that's a skill set for your entire life. It's not just math. This is just the logic for how to do it. And that's one of the main skills that you're going to learn in high school, even if you don't end up using exactly this. So let's look at this. We need to find angle x, and it's right here, right there. So we have to use a couple things. So I'm going to turn my attention to this part of it, because we only mess with two parallel lines and a transversal one at a time. I'm going to look at just this part of it, just this line and those bottom two parallel lines, just the bottom transversal and the auxiliary line I made and the bottom line. Using that, I can use corresponding angles right here. Notice if you see with this line right here and that bottom line, that this x is a corresponding angle with this part of 72. But that's just that part of 72. It's not the full angle. We got to remember that 72 is this whole thing. We don't know what this is, but we just kind of need to make sure that we understand that that's a corresponding angle with x. So whenever we figure out what that is, we're going to be good. So, and sometimes we can, use symbols like this. So like say that this angle and this angle are congruent. And we know that because they're corresponding angles. Now, if I turn my attention to this part right here, to the actual angle measure that I know, and not start off on the wrong thing, we can look at this and say, all right, well, this right here is a corresponding angle with this. And it really doesn't matter what symbol you use. Sometimes we use that angle thing. Sometimes we use a double angle mark. Sometimes I like to do little symbols on that. So this is usually your typical thing if you're talking about multiple angles being congruent. But we know this part of this angle is 35. Because it says so right here. It's a corresponding angle. So when I justify my solutions, I'm like 35 degrees is a corresponding angle to the angle made by the auxiliary line right here. And we can label it, call it something, doesn't really matter. But since I know that this part of this angle is 35 degrees and the full angle is 72 degrees, I can find the remainder by doing 72 equals 35 plus whatever this is. I can call it x. It is x. It's a corresponding angle. And then so 72 minus 35 equals x. So we're looking at what is that? 37, I believe, equals x. I do believe it's 37. Let me check just to make sure we don't waste any time. Yes, it is. Now, the teacher's edition really likes its explanation. I don't really like a lot of them, but it says the angle with the measure of 72 degrees can be divided into two angles. They have a typo there. One measures 35 degrees, corresponding angles. Then the other angle has a measure of 37 degrees, partition property. The partition property is just fancy words for saying that this part of it is a partition of the full angle. So we can subtract it off from the full angle. The sum of three angle measures of any triangle is 180 degrees. I might share with you the animated GIF that I that I've seen before that shows why. And it's because if you take all the angles in it, it actually ends up, and you lay them next to each other, it ends up making a straight line, no matter what you do. If you pick it up and rotate it. I could see if I can do it right now with any old triangle. Let's see. I want to make it look kind of wonky. There we go, something like that. Let's see if I can do this well enough. Now, this is always a mistake. Let's go ahead and copy it and paste it and kind of rotate it a little bit. Let's see if we can do this and make it look nice. Kind of just put them all at having a shared vertex. Let's see if this works. Doesn't really matter the size. It'll be a similar triangle either way. It's kind of difficult to do. I'm going to share the animated GIF. Interior of a triangle. The point lies in the interior of a triangle if it lies on the interior of each of the angles of the triangle. In any triangle, the measure of the exterior angle is equal to the sum of the two measure of the opposite interior angles. Opposite interior angles. These are sometimes also known as remote interior. And then the base angles of an isosceles triangle are equal in measure. That's going to be important for us once I remember how to spell isosceles, I'm pretty sure. Is it something like that? I think it is. And then each angle of a blank triangle has a measure of equal to 60 degrees. Well, that's got to be an equilateral triangle. If they all measure up to be 180 and each one of them is 60 degrees, it has to be an equilateral triangle because all three angles are the exact same thing. So let's just remember, an isosceles triangle is a triangle with at least two sides of equal length. So usually when we represent something like this, we put a little line like that to say that they're equal length. There might be double lines, and that way we can figure out how to which triangle we're talking about or which part of it we're talking about. Angles of a triangle. Every triangle ABC determines three angles, namely those things are called the angles of ABC. So these are just listing off the vertexes. The middle one is the actual point of the vertex. And an exterior angle of a triangle is if there's an angle that is the interior of a triangle, ABC. D is a point on AB on one of the lines of the triangle, one of the sides, such that B is between A and D. Then CBD is an exterior angle of the triangle ABC. We're going to show pictures of this and talk about this in a little bit. So let's talk about something like this. So we need to figure out these unknown angles. Find the measures of angle A and B in the figure to the right and justify them. So really, we're not going to go in this with like a rote, memorized way of doing this. We're going to kind of look at all this stuff and kind of, my dog was about to bark. And let's see what we can do with this. All right, looking at this, what do we know? Right here, we have two angles. So we can partition this into as many triangles as we want. Like this is one. But this is also one that contains the other one. So that's going to help us a lot. We just want to be able to kind of, and this is another one, by the way. This is going to enable us to be able to look at one at a time. So we have to develop the skill just to look at one triangle at a time, even if it's inside of another one or sharing sides with another one, it doesn't matter. We want to be able to focus in on the parts that we need at any given point. It does, as long as it's a triangle, it's going to follow all of our properties the same way. So if I look at this, I have two angles inside of a triangle. Whenever I have two angles inside of a triangle, I can find the third one really easily. So I'm going to take 69 degrees plus 58 degrees plus A and set that equal to 180 degrees because we know the property that all of the angles, all three angles in a triangle add up to be 180 degrees. So 69 degrees plus 58, so it's 127, I believe. And then we subtract off that 127 using a little bit of our algebra to get A equals 180 minus 127, which I do believe is like 43. think it's 43 degrees. 53. Ooh, none of y'all stopped me. 53 degrees. Yes, 180 minus that, 10 minus 7 is 3. Drop that. 17 minus 12 is 5. All right, good. So now that we know that, we can turn our attention to this big triangle, either this part or just this part. We need to figure out what we need. Well, we don't know what this is, and we don't know what this is, so we don't have enough information yet. So let's kind of look at the given parts of it and see if we have any straight line angles we can use. Well, here's a straight line angle. I need to figure out what this is, and I need to figure out what this is before I can actually figure out what B is. So let's look at it. All right, well, this angle right here, because I don't have any other letters, I'm going to call this X and Y just to make it easy. I could call it Greek letters. It doesn't really matter what I call it. I just kind of need something to manipulate. No matter what, though, B plus X plus Y equals 180. I just need to figure out what X and Y are, plug them in, and figure out what B is. So I have to take a second to look at what our properties are. It certainly looks like I have a straight line angle right there. I have a pair of consecutive angles on a straight line, so they add up to be 180. So X plus 69 degrees equals 189. Subtract that off to get X equals 180 minus 69 is 111. I believe it's 111. Yeah, I think so. So this is equal to 111. So we know one of our angles. So far we have B plus 111 plus Y equals 180. We still need to figure out what Y is, though. Do I have any other consecutive angles on a straight line? Oh, wait. We got all the angles here. We got 3 of them. So I wouldn't call it a linear pair, even though technically they use that term a lot. All right, well, 58 plus 93 plus Y equals 180, because straight line angles. 58 plus 93, 151, I think. I think so. 151. Okay. Well, subtracting off 151, and I get Y equals 180 minus 151, 29 degrees. 29 degrees, allegedly. If I make an arithmetic mistake, the logic's still the same, even if the numbers end up being incorrect. One of the main things about geometry is explaining your reasoning. It isn't necessarily as much about ciphering. So B plus 111, that's X, plus, now we have 29 for Y. So B plus 111 plus 29 is going to be 140. Subtracting off 140, B equals 40 degrees. So B, we figured out to be 40 degrees. So A was 53, and B was 40. So if we add B, A, and so if we add A, B, and 29 plus 58, we should get 180. I'll let y'all do that to confirm. Just double check me. Okay, we have another triangle. This one's actually going to be super easy. The first, I want you to think to yourself, what do you notice first and foremost about this? I notice that I need to find A, but I don't have this. If I had 2 angles in the triangle, I could easily, always, first things first, add them all together and see what will make that 180. But I don't have this part right here. I have this part, and that is a linear pair with that. So 180 equals whatever this is. I'll call it X again. I like doing that. X plus 78. 180 minus 78 equals X when I subtract 78 from both sides. So it looks like it's 102. So it looks like X equals 102. Unless I made an arithmetic mistake. But we'll find out, won't we? So that means that 42 plus 102 plus A equals 180 because all the angles in a triangle add up to be 180. So this is 144 plus A equals 180. Subtracting off 144. A equals, is that 36 degrees. I believe that is 36 degrees. And you can always confirm your work by slapping the numbers back in there and seeing if they add up to be 180. So these types of problems are the ones that are really pretty easy to kind of go through. Man, every time I see a straight line like that, I think to myself, man, linear pair, got it. We've got 68 degrees. I don't know what this is, unfortunately. I don't know what this is. I don't know what this is. So it kind of makes it difficult. One thing I do know, though, is that if I turn this thing to the side, like it's hard for y'all to do it, but you can do that with your books. If I turn this thing to the side, like this, notice you can more easily see that you have an isosceles triangle. Let's use what we know about this. An isosceles triangle, its base angles are the exact same as each other. So this has to be 68 degrees because it is an isosceles triangle. That is a property of an isosceles triangle. And there's so many proofs about it, and y'all probably either did them or read them or watched them or something or got told about them in 7th grade. If I can remember, I might link a couple videos that show you the proof instead of doing it in this video because I want to make it short enough for you to watch it. So if this is 68 degrees and this is 68 degrees because it's an isosceles triangle, then 68 plus 68 plus whatever this part is, I'm going to call it x again. You can call it whatever you want. That's equal to 180 because all the angles in a triangle add up to be 180. So 68 plus 68 is 136, I believe. And if you're curious why I'm trying to figure out this, the only information I have is that one angle and the fact that it's an isosceles triangle. So figuring out this will let me figure out this whole thing. I kind of thought ahead about, like, how can I figure out this so I can figure out this so I can figure out that. So subtracting 136 from both sides, and I get x equals 44 degrees. So x equals 44 degrees. So this part right here is 44 degrees. But that's not what it asked me. It didn't care what x was. It didn't care what this angle was. It cared about what b was. So we're going to use the fact that consecutive angles on a straight line are supplementary. So b plus x, b plus 44 equals 180. I invented x. I just called this angle x just to make it easy to write. So b equals 180 minus 44 is 136. Now, interestingly enough, you could also use the property that we learned earlier, if you want to do it in a different way, and realize that this angle must be the sum of these opposite interior angles right here, these remote angles. So b is equal to 68 plus 68, which is 136. That's a faster way to do it, but it doesn't show you exactly what's going on as much. It's just relying on a memorized property. Now, if you don't notice that or you don't remember that, don't worry. You can always show it to yourself by rederiving it. Okay, so a couple bits of information I notice about this problem. Obviously, I'm going to have to find C and D, because they're the only variables I have. So, I mean, that's one thing. But it usually means I'm going to have to find other parts of it. One thing I notice, I have a right angle here. Probably going to end up using that. But it's split up, so D is just part of that right angle. It's not 90 degrees. It's just a part of it. So I kind of say to myself, I'm probably going to end up having to do 90 minus D at some point. Or D is equal to 90 minus whatever I figure out this part is. So that's just a thing I commonly do. So let's look at this. So I can look at this in three different ways. I can look at this as just this triangle, this left triangle. I can view it as just this right triangle. Or I can look at the entire encompassing triangle where both of them are part of. I think I might want to find C by looking at the full triangle. Okay. Looking at the full triangle, I get 90, this whole thing. I get this plus 64 plus this, and that's going to be 180 because all the angles in a triangle sum up to be 180 degrees. So I get 154 plus C equals 180. Subtract off 154. And again, the reason I did the big triangle is because C, that was the easiest way. I knew all the angles except for C on that triangle. And you're going to have to develop the skill of abstracting it to the full big triangle or looking tiny at the tiny parts. C is equal to, what is that, 26? I believe so. I believe it's 26. So yeah, I think we're good on 26 on that one. So now we need to figure out D. So I know a couple things. D is part of this triangle. I don't know this angle right here. Let's just call it X. And I don't know, and I know what this is. But I can't just use 90 in this case. It's not going to help me. Now I could figure out what this part is. There's two methods to go about this. Let me show you both of them. The first method I'm going to do is I'm just going to look at this right triangle right here. And I'm going to say, I need to figure out X. Well, I'm going to do that by using a linear pair. 95 plus X equals 180. Subtract 95 to get X equals 85. I do believe that's 180. That's 85, so subtracting off that. Yeah. So this is 85. So now I have all the angles in a triangle add up to be 180. So 85 plus 64 plus D equals 180. 85 plus 64 is 149. Subtract 149 off. Doggo's boofing. 180 minus 149 is what, 31? I believe. 31 degrees. This was using method 1. And again, the way I did this is you want to write down the words that you use as you take a step. So you can say something like looking at the large triangle, maybe you label the vertices as something so you can more easily use your words, and say that, because all the angles in a triangle sum up to be 180, 90 degrees, and then show your work, and then say, therefore, C is whatever. And then on this one, you can say, because 90 degrees and the angle right here that you can call whatever you want are linear pairs, they add up to be 180. And then you can say, now, looking at this triangle, label the vertices probably. They'll probably be labeled whenever you do them on the leap. And then say 85 plus 64 plus D is equal to 180 because all the angles in a triangle. Yeah, basically, the words just have to show that you know what you're doing. But there's another way to do this. Another way to do this was using C. We can realize C is 26 here. And then we can say, all right, well, we have 26 plus 95 plus whatever this angle is. 26 plus 95 plus, I'll call this Y because I've already used X. All these angles add up to be 180 because they're all the angles of this left triangle. 26 plus 95 is 121. I believe. Is it 121? I believe it's 121. And then subtract 121 away to get Y. That's equal to 9. It's 59. So this is 59 degrees. So realizing that these two angles are complementary because they form a right angle together. And you get 59 plus D equals 90. Subtract 59 off to get D is equal to 31. Hey, that's exactly what we got already before. So no matter which way you do it, you're going to get the same answer. All right, so I'm going to go ahead and stop the video right now, and we will do the rest of these in a separate video. Actually, hold on. Maybe we can, let's go ahead and just look at this one first. There's a lot of ways to do this, so I just want to point out there's like the way I do it. If you notice something differently and it follows all of your properties and you get the same answer, that's fine. That's fine. Unless you're told to do it a specific way to practice that skill, it's okay. I'm trying to find E here. I don't know what E is. This is not a triangle right here. This is a triangle. This is a triangle. These two separately are triangles, but this is not a triangle. So we can't use our triangle stuff on that the figure that E is in. So we're going to have to do it a little bit differently. One thing I can do is I could figure out what this angle is to figure out what this angle is to figure out what this angle is. Can you tell why? Now, I hope your answer was something like this is a linear pair, so it's going to add up to be 180, so I can figure out that. I can figure out this angle from the fact that once I have this angle, I can figure out this angle by adding them all up and make them equal 180. Then I can figure out this because it's a linear pair. Looking ahead will often save you time. So let's do that. Let's figure out using a linear pair with those two angles to figure out what this is. I'm going to call this X, I'm going to call this Y, I'm going to call this Z, just because I just like doing that. You don't have to do that at all. You can just, if you can keep track of it yourself, that's fine. I just always recommend using a variable or something that's so you can write an equation so you can prove it to yourself instead of having to hold it all in your head. I promise you, as a person who used to do mental math all the time, then kept making tiny, tiny mistakes that would throw me all off, that is my advice, is to self-police that. So let's figure out X. I know that 115 plus X is a linear pair, so it's going to be supplementary, which means it adds up to be 180 degrees. So X equals 180 minus 115 is 65 degrees. 65 degrees, I believe. So this is 65 degrees. This is the third angle of a triangle where I have two other known angles, so I can add them up to be 180. So I get Y plus 65 because that's X plus 34 because that was given equals 180 because it's supplementary. So Y plus 99 equals 180. Subtract 99 using our algebras. Y equals 180 minus 90 is 90. Minus 9 more is 81. That's one way to do the mental math. You can use a calculator too. You can do borrow from this and say that that's 10. There's so many different ways. I'm not going to belabor the arithmetic on this, but just some tips and advice that there are a bunch of tricks to do mental math really fast. But this is 81 either way. Unless I goofed. Watch out now. So 81 plus Z, that I've just labeled that as equal to 180 because these two are linear pairs. Subtract 81. And were there other properties that you could use? Yeah. But often I don't remember that property about like remote exterior, remote interior, stuff like that. Sometimes that just falls out of my head and I have to show it to myself different ways. But you could totally do that. That's fine. So Z is equal to, 99? Yeah, Z is equal to 99. Now, that was useful. The reason I found out this angle is because this angle, and this angle are the three angles of this triangle right here. If I add up 99 plus 30 plus E and set it equal to 180 because they all add up to be 180 degrees inside of a triangle for all the angles, I get 129 plus E equals 180. Subtracting off 129, and I get E is equal to 51. 51, I believe. I don't really have the thing up to confirm most of my solutions, so 51 degrees. All right, well, may as well just do this one too, because I'm seeing parallel lines, which means I can imagine a transversal. And maybe you want to show it to yourself. When you have two parallel lines and another line connected to it, you have a transversal. If you want to extend these a little bit mentally just to see it more evidently, because that can sometimes help. Like that, then you're sure, yeah. Because right here, I know that I want to find F, but I need this angle. I noticed a couple things. I noticed I have parallel lines and a transversal, even if it doesn't quite look like it. So that means I have a corresponding angle right here. Were there other ways to do this? You betcha. You could have used alternate interior angles. And then found this either way. It doesn't really matter. But that's a vertical angle. We knew that should be equal, so that's a good checking point. So I know to find this angle, because I need two other angles inside of a triangle, on the interior of a triangle, to find out what that is. Unless I have something else I could use, but I don't in this case. But I know that this is a linear pair, so 78 plus, let's just call it x, equals 180. Because it's a linear pair. X equals 102. 102. Don't write 120. 102. So now that means that I have all the angles except for one in here, so I can add them up and set it equal to 180. That's a plus sign because I accidentally almost wrote an equal sign. But all the angles inside of a triangle add up to be 180, so that helps. 150 plus F equals 180. Subtract 150 to get F equals 30. And yeah, there are so many cool ways to do this. Obviously, we're going to use a transversal on this one as well. This one actually might be one of the easiest ones that we could possibly do. But we will come back to that in the next video.